Namaskar, my dear friends. Welcome to the lecture series of computer-aided manufacturing. In our previous lecture, you will learn about the flexible manufacturing system. In part 3, the automated guided vehicles and different FMS layout. Okay, now in this lecture, you are going to learn about the automated storage and retrieval system, then workpiece handling system and flexible fixturing. Okay, now let us start with the automated storage and retrieval system. Okay, so first of all, the introduction of automated storage and retrieval system. So in large manufacturing establishments, the volume of items to be stored and retrieved, it becomes so large that the manual means of doing so become extremely unreliable and time consuming. So the large volume also call for the proper information management procedure in order to reduce the duplication and reduction of inventory cost. Okay, so this automated storage and retrieval system, it is known as ASRS. Okay, so which is the handling and storage systems which integrated into the manufacturing and distribution processes. Okay, so this automated storage and retrieval system play a central role in the automated factory. Okay, so the ASRS not only control the inventories but also keep track of parts and materials in process or transit. So in other words, we can say the ASRS has the ability to know where everything is on a real-time basis, even as the material moves within the factory. So the importance of it for management to make manufacturing decisions based on accurate real-time information can be understood from the fact that in process material rarely spend more than 5% of their time being worked on, and that the remaining 95% is spent in transit or storage. So thus it becomes easier to visualize the role of material handling and storage system within an automated factory. This ASRS is used for the storage of typically the heavy loads of finished goods, work in process, raw material and supplies. Okay, so the main components of the ASRS are storage and retrieval machines. Okay, that is known as shuttle crane or stacker crane. Then storage structure, transport devices which are AGV, conveyor and controls. This ASRS sometimes also referred to as automated warehouse and is a combination of equipment and controls, so which handles the stores and retrieves material faster and with greater safety and efficiency than the conventional material handling and storage systems. So ASRS contains the several rows of storage racks and storage retrieval devices. Okay, here you can see the typical ASRS with its component parts. Okay, so the system can be linked to the other external devices such or automated guided vehicles for transferring material in trays or pallets to the shop floor or palletizing stations. So here you can see the typical ASRS with their components. Okay, so the incoming items are first stored and assigned to pallets. Okay, so here you can see this part is a pick and deposit station. So the pallet loads are then routed through the weighing and sizing station. Okay, weighing and the sizing station here you can see to ensure that they are within the load and size limits. Okay, so the accepted ones are transport to the pickup and delivery. Okay, here pickup and delivery, a P&D station with the details of pallet content, okay, which communicated to the central computer. Okay, so this computer assign the pallet a storage location. Okay, storage location in the rack and store the location in its memory. So the pallet is moved from P&D station to storage by storage and retrieval machine. You can see this is the storage and retrieval machine. Okay, it moves okay up and down and on this side, or it is known as the stacker crane. Okay, so upon receipt of a request for an item, the computer will search its memory for storage location and direct the stacker crane to retrieve the pallet. Okay, retrieve the pallet. So the supporting transportation will transport the pallets from P and D station to its destination. Okay, so the four components can say storage and retrieval machine, and then storage structure. You can see this is the storage structure. Okay, rack framework, then transport devices. Okay, AGV conveyor and controls. Okay, these are the different storage module. We can see the pallet loads. Now you can see here this is the length of this ASRS and this is the height of the ASRS. So now let us see the different components. So first is the storage and retrieval machine. Okay, it is known as the SR machine. So this SR machine is characterized by its ability to operate accurately and safely at high speeds. Okay, at high speeds, it reach heights of 30 meter or beyond and operate in SLA only a few centimeter wider than the load it carries. So the modern SR machine can run on a floor mounted rail and guided at the top. So it comes in a wide variety of sizes and configurations because its design is a function of the load it carries and the task performs. Now, speed is generally determined by the system's throughput requirements. That is the how many loads need to be stored and retrieved in an hour. So the traveling speeds sometimes exceed 150 meter per minute, while hoisting speed can be as high as 50 meter per minute. Okay, now you can see here, this is the physical arrangement of the assay and storage structure in an automatic and retrieval system. Okay, you can see the rack 1, okay, rack 2 and 3. Between this is the assay 1, assay 2, assay 3. Okay, the different racks are given. Here, this is the peak and deposit, P and D station. Okay, this is the P and D station. Stacker crane, which is useful to load the material. Okay, and interface conveyor or AGV line. This is now the next one is the storage structure. So the storage structure, okay, it is racking, known as the racking, is a critical part of ASRS. So it differs considerably from the conventional pallet racking in that this ASRS storage racks are normally much higher and interface directly with this SR machine. Okay, so thus making the manufacturing and installation tolerance more critical. Automatic storage and retrieval system rack design, it must provide for integration with SR machine guide rails. Okay, SR machine guide rails. So the most common storage structure are freestanding and installed inside a building. Okay, the specifications differ depending on type of load to be stored and system configurations. Okay, so today an increasing number of systems are rack supported. Okay, so that is the rack storage structure supports the building itself. So this type of system can be over 30 meters tall and is popular because it reduces construction time and cost. Then next one is the transport devices. So the transport device it moves the load, okay, moves the loads beyond the limit of the SR machine. Okay. So some systems need only a conveyor, while larger and more complex installations require elaborate transport devices connecting the SR with other factory operations. Okay, so there are many types of transport devices which can be used with an ASRS. Forklift, roller or chain conveyors, overhead power and free conveyors, in-floor tow lines, shuttle trolley, and automated guided vehicles. Okay. So the choice depends on the throughput requirement, type of load to be handled, and degree of attraction with shipping, receiving, manufacturing, assembly, and other plant operations. Okay, so here this is an example system that links with the conveyor and AGV. Okay, this figure which shows an example system that links with a conveyor and AGV. Okay, so physical layout of ASRS link with AGV for the further movement. Okay, here you can see this is this track which show the AGV track. Okay, here it is the input station and this one is the input conveyor. Okay, and these are the storage racks and here is the crane. Okay, and this one is the out conveyor. So from that you can see the AGV, automated guided vehicle, which moves the part. Okay, and this is the workstations. Okay, so this is the physical layout of ASRS linked with the AGV for the further movement. Then next one is the system controls. So the system controls, it encompass two functions, the controls of equipment and the control of data. Okay, so this computer control system may also perform tasks like inventory control, data automation, networking control, and is frequently linked to an even a larger corporate management information system computer. Now, some definitions and conventions, okay, or some terminology of the ASRS. So, first one is the storage structure. So, it is the rack framework that supports the loads contained in the ASRS and is used to store the inventory items. It is called the storage structure. Then storage racks. So, the structure entity, it comprises storage locations, bays, rows, okay, etc. Then storage space. The three-dimensional space in the storage rack used to store a single load unit of materials. Then bay, the height of storage rack from floor to the ceiling is called the bay, or we can say simply the height of the storage rack. Then row, a series of bays placed side by side is called the rows. Okay, the series of bays placed side by side. Then ashley, the spacing between two rows for the machine operations of ASRS. Okay, the spacing between the two rows is called the ashley. Then ashley unit, that is encompasses ashley space and rack adjacent to an ashley. Okay. Then as storage and retrieval machine, which is used to move the items in and out of inventory. So an SR machine is generally capable of both horizontal and vertical movement. So in the case of fixed ashley storage system, a rail system along the floor guides the machine along the ashley, and a parallel rail at the top of the storage structure is used to maintain its alignment. Then storage module. So the unit load containers used to hold the inventory items. In the industrial world, these include the pallets, steel wire baskets, and containers, pans, and special drawers. So in the laboratory environment, this may include the vials, plates, bottles, etc. So these modules are generally made to a standard base size capable of being stored in the structure and moved by the SR machine, storage retrieval machines. Okay. Then pickup and deposit station, that is the PD station, where the inventory are transferred into and out of the ASRS. So they are generally located at the end of the ashley to facilitate easy access by the SR machines from the external material handling system. Okay, so the location and number of PD stations depends upon the originate point of incoming load and destination of output loads. Then cherry picking, the process of the ASRS assessing any individual unit load container regardless of location in the storage system and position in the access sequence. Okay. So in the laboratory environment, the cherry picking may also involve the randomly accessing a given subunit within a load container. That is a given sample within a multi-sample container, such as a microplate or array of vials. Okay, so this is all about the different terminology used in the ASRS. Now the advantages of the automatic storage and retrieval system. Okay, so absolute inventory accountability is one of the most important benefit of an ASRS. Okay, so by knowing exactly how much of what material are located at any given moment, so inventory reductions are quite common and higher reductions are frequently realized. Okay. So in addition, this system discourages the pilferage and generate the very little product or equipment damage. So the system can also improve customer service and working conditions and thus results in less indirect costs associated with supervision, administration, facilities, and security. Okay. So apart from this, the different advantages of the ASRS are better space utilization, less direct and indirect labor, reduce inventories, less energy consumptions, reduce pilferage, less product damage, improve working conditions, easier housekeeping, less equipment damage, improved customer service, and better management control. So these are the different advantages of the automated storage and retrieval system. Okay. Now let us move further. The workpiece handling system. Okay. So this workpiece handling system has the functions of timely supply of on-machine workpiece from the storage to the machining center and transporting the machine parts from the center to the locations. Okay. So this block is generally consists of the three modules. Okay. Workpiece setup or loading and unloading station, workpiece store, and workpiece transport. Okay. Now let us see uh, workpiece setup or loading and unloading station. So prismatic components it made for machining centers are generally set up on pallets. Okay. So the pallets are nowadays standardized to have the compatible mechanical interface with the storage locations and transport system, pallet changer, and the machining centers. So the palletization may be done manually or with the help of a robot. So fixtures are used to locate the parts precisely on the pallet. The fixture should be able to accommodate several parts belonging to a family. Principle of group technology are generally employed in these connections. Okay, so the fixtures may even be permanently fixed to the pallet, which in turn may also have the provision for automatic clamping actuated hydraulically or pneumatically. So several setup stations may be combined to constitute a central clamping and unclamping station. So when the workpiece have relatively low weight and size, they may be directly loaded onto the machine by a robot or a manipulator. So in such cases, the workpiece may be loaded manually or automatically on tray like a pallet. So a transport pallet of this type may be used to accommodate the several workpieces in proper position. So rotational workpieces may also be loaded into turning centers in a similar fashion. Okay. Then workpiece store. So pallets with workpiece on them may be stored in expandable workpiece stores. Okay. So the storage position for each of the pallets may be fixed or alternatively uh, identified as explained in pallet workpiece identification. So such stores may be used as buffer storage points for an unmanned shift. Okay. So workpiece storage and retrieval can also be automated in FMS. Okay, so an FMS is generally a small lot but the great variety manufacturing system involving frequent modification of parts and workpiece changeover on the pallets. So at the same time, the minimization of setup time is one of the prime objectives in FMS. So in this respect, ASRS is gaining wider acceptance for becoming a centrally controlled pallet workpiece store working unmanned around the clock. So the number of pallets which can be stored may vary between 500 to 10,000 for small scale to large scale ASRS. Okay. So the system essentially consists of storage racks, a PLC base or the computer control stacker crane, the location and accuracy of which is comparable to that of a robot. So employment of a servo motor in the crane helps to achieve positioning, accuracy and reliability. So elevating speed of the stacker could be as high as 180 meter per minute. So the ASRS computer is also networked in the LAN of the FMS for necessary data processing and integrated operations. So several software modules continue to be developed to enhance ASRS functioning so as to include the storing of several types of workpieces. Okay. So setting up the rearrangements and real-time changes and positioning and allocation of CRAN and optimum utilization of ASRS. Then next one is the workpiece transport. Okay. So the three devices are used for transporting the workpiece from the store to the machine, that is the rail mounted transport vehicle RTV, automatically guided vehicle AGV, and gantry robots GR. Okay, so that RTV can carry workpiece from the store or setup station to all those machines which can be interlinked with rails. So this may sometimes impair access to the machine but offer a reliable transport traveling at high speed on linear routes. Okay. The AGV, on the other hand, do not require any rail and transport even over non-linear routes and are widely employed. So most of these unmanned industrial trucks are inductively controlled and consequently move at lower speed than RTV. So several AGV may be used in the FMS to cover all the routes. Then gantry robots, which are essentially mobile, may be used to load the workpieces directly onto the machines from the pallets which store workpieces. Okay, so this of course requires the robot grippers which suits the workpiece geometry. Further, the components should not have large dimensions and their weight should be small. So it may be noted that in this case, the several of the expensive fixtures which would otherwise be used to mount the workpiece on the pallets are not required. Okay, so alternatively, a gantry robot moving along a linear overhead gantry may be used to transport workpiece set pallets from the store or setup station to the machines. Okay, so this is about the workpiece transport. And last is the flexible fixturing. Okay, so a flexible or adaptable fixture has been defined as a single device that holds the parts of various shapes and size that are subjected to the wide variety of external force, fields, and torques associated with the conventional manufacturing operations. So the flexibility is a property of the fixturing device that makes it conform to the workpiece geometry. Okay, so the different advantages of these flexible fixturings are reduction in lead time and effort required for designing special fixtures, lower overhead cost of storing a multiplicity of fixtures required to effect a rapid changeover between different manufacturing operations, and simpler programming requirements. Okay, so design of various resettable fixtures for use in an FMS have been proposed. So these fixtures have a common location scheme for a group of workpiece, and just resetting the clamping element is required when the new workpiece is introduced. Okay, so a number of individuals have surveyed the flexible fixturing methodologies. So broadly, there are two major groups of flexible fixtures, that is discrete contact and continuous contact. So in the discrete contact type, there are a finite number of contact points that can be arranged in a space to give the different configurations. A continuous contact fixture is a fixture in which the number of contact point is infinite, such as a line or area contact. Okay? So a point contact would completely constrain the motion in a direction normal to the workpiece surface only. So the motions parallel to the workpiece surface would not be completely constrained because of the limited friction in point contact. So surface contact would not only constrain the motion of the workpiece along the three axes, but also would constrain the applied moments. Okay. So I hope now you can understand very well about the flexible manufacturing system. Okay. So thank you very much, friends. Thank you.